U substitutions are the opposite of the chain rule. Just like we have the chain rule and for derivatives, for differential calculus, U substitution is the equivalent of that for integral calculus. And just as the chain rule is the most important thing in all of the derivatives, U substitutions are the most important things in all of integrals. Let's take a look at how you actually do it. I'm going to show you this by example. You're going to watch this video 5 or 6 or 1,000 times until you start to get the hang of it. You'll practice it a whole bunch. But let's go ahead and get started. So the U, when I say U is going to end up being the thing that's like inside the parentheses somehow. So in this case, U is x squared plus 7. So over to the side here, I'm going to write U equals x squared plus 7. And then I'm going to do the derivative of both sides. But here's what I'm going to do. I'm going to write the derivative not as u prime, but as du over dx. Du over dx equals 2x. Okay? Now, we're kind of close here. We don't have a 2x, we have an x. So what we're going to do is, let's get rid of that. We're going to literally just put a 2 here. We're going to make this a 2x. And to balance that out, we're going to put a 1/2 on the outside. That's that classic rule, the constant multiple rule for integrals, that says if you, like whether you have something like, say, let's say we're just doing the integral of x, whether you have 2x like that, or whether you have a 2 out here, it's the same thing. So 2 times integral of x is the same as the integral of 2x. And what that means, on a nice practical note, is if you have the integral of 2x with a 1/2 out here, that's the same as having the integral of 1/2 times 2x, or the integral of x. So that's why we can put that 1/2 out there. So I'm going to kind of clear away some of this stuff here, and then show you how to actually use this U substitution. So we have this U substitution. We realize that U is x squared plus 7. Over here we've decided that du over dx equals 2x, or that du, we're going to multiply both sides by a dx, is equal to 2x times dx. So over here I have the du. And so I end up with this 1/2 times the integral of cosine of u times du. Now notice over here that the variable and like the d variable are the same. That's what you want. If you have an x, you want a dx. If you have a u, you want a du. If you have an a, you want a dA. They have to match in order to do the integral. So now we're going to just go ahead and literally do the antiderivative. We're going to get 1/2 of sine of u plus c. But what's u? I mean, we started this question with x. We can't give the answer in terms of u. That would be a laughingstock. So let's actually go ahead and remember that u is the same thing as x squared plus 7. So I'm going to replace this u with this x squared plus 7 and end up with 1/2 of sine x squared plus 7 plus c. And there you have it. That's how you do a U substitution. Remember, the U substitution is the integral thing equivalent of the chain rule for derivatives. It is you're going to use this the most. This is the tool you'll use the most often. It is just as important for integrals as the chain rule is for derivatives. Now, feel free to rewatch this video as much as you like, and then when you're ready, we're going to actually practice with some real U substitution problems.